Cool. So, hey everyone. Today I have somebody joining in from Vancouver, BC, who actually goes to the British Columbia Institute of Technology. Where is that school based? Or yeah, where in Vancouver is it? Or is it even in Vancouver? Because BC is the province.
Yes. So there's like what, I think five campuses. There's
Mm,
one, the one I'm primarily located at for like the tech, like the computer science stuff is either Burnaby, BC or Vancouver, BC downtown.
I see. Where's your campus? Is Burnaby?
I usually alternate between downtown and Burnaby, but I think
Nice.
actually honestly majority downtown. Yeah.
Okay. What program are you taking there?
So it's called the Computer Systems Technology. Um, that's kind of the name of their diploma, and that goes into their bachelor's, which is just a bachelor's of science, computer science.
I see. And
Yeah.
then okay, so it feeds. Are you planning to take a full degree?
Um, that's kind of what I'm just determining right now because I'm kind of in an interesting situation where I might have the chance. Um, for example, if I get a RO, I can finish my bachelor's part time. So if that does happen, that's probably the route I'm going to take.
Yeah. Or as
Yeah.
in get a full-time job and just keep chipping away at your bachelor's
Yeah.
at it. Okay, that's cool. So what year are you in and what have they taught you so far?
So right now I'm finishing my second year. What they in terms of what they taught me, do you want to know like everything or like is there specific areas like just
Yeah,
like
what computer science courses have you taken so far?
so thinking like uh data structure or the first level of data structures and algorithms. I've taken some computer architecture,
Hmm.
Java, Python, object oriented,
Okay, nice.
C++.
Wow,
And
teaching you a lot then.
yeah, and then we have really good electives, so I was able to take like React, Vue, Angular, Node.
Wow.
Yeah,
Wow, that's no, that sounds like a really good school actually. Super,
yeah,
it seems also super applicable. Not like some
yeah.
random
That
stuff
that
they're
one's
teaching
all
you.
about hands-on, like getting you ready for the job. So that's
I
what I
like
like.
that. Cool. So how has the leak coding been for you? How many questions have you done? How has it been to sort of wrap up on that?
Um, it's been good. I think I've done about 120-ish questions. I feel like there is several areas where I feel like are weak
Hmm.
that do need to improve on. I just haven't really gotten the chance to build upon that yet. That's more of something I'm looking to now.
Yeah.
Um,
What are those weak areas?
some of the weak areas, I think one would be graphs. I do have a somewhat of an understanding of graphs, but it's definitely, I think I struggle with questions that kind of get a little more complex. Like a number of islands is like fine for me, but rotting oranges is a bit more to get wrap my head around. And then I had a TikTok OA the other day. They had I think it was a graph question. It was like placing Tetris pieces on a grid paper.
I see.
That one was pretty challenging. Um, and then I think sliding window, I didn't fully learn like the proper ways of going about it yet.
Hmm.
So that one was a bit difficult for me as well. But I'm sort of learning, I guess, picking up more on it.
Yeah. So what's sort
I
of your
haven't
process for studying your certain
studying.
questions? Yeah.
So recently, what I've been doing is I've been, for example, using LeetCode, going through the data structure, learning the data structure, and then picking up some algorithms, and picking up any information that is in the curriculum from LeetCode, and then applying it,
Hmm.
and then trying to guess solve, for example, blind 75 questions that are in that category, and trying to see if I can, I guess, come up with a solution, optimal solution myself. And if not, then I'll obviously have a look and see what I can improve.
Mm-hmm. Okay. Cool. All right.
That's kind of mainly it.
I'm
Yeah.
gonna send you the link then. Do you
Okay.
think that your school has? Oh, you're in. Do you think that your school has prepared you enough to actually learn lead code fast, or it's been kind of a struggle to pick up on lead code?
Um, so for my data structure course, it was kind of like we covered like obviously hash map sets, but then after that we kind of touched on topics like they did a little bit of dynamic programming, a little bit of like this and that. There is supposed to be a more advanced one coming up that I haven't taken yet, but I didn't really, I guess, in a sense, learn too much because I was already kind of working with hash maps and sets, stuff like
I
that.
see.
Um,
Cool.
yes,
All right.
yeah, I guess, yeah. But I guess before we begin, I should probably tell you that I do have an interview on Tuesday, which is why
Nice.
I wanted to do this mock.
Cool.
It's for SAP,
Nice. I know
and I
someone who
know
worked there
that
before.
yeah, and I know, I think they're known, since it's an intern position, they're known to ask questions like, I've heard like ransom notes, best time to buy and sell stock, to some stuff like that. Nothing too crazy. And then it's either, I think, two easies or one medium. I'm not sure.
Two easies and one medium.
Yeah, two
Okay.
easies or one medium. I guess it depends on the interviewer. But yeah, so that's kind of what I'm preparing for right now.
I see. Have you already done the best time to buy and sell stock question?
Yeah, so I've done, yeah, I've done that one.
Okay. All right. So I'll just give you the first question. I was about to ask you that question literally, but let's move on. Let's start with this question. This is the
Okay.
first question. Go ahead and read it and let me know if
So
you have
given
questions.
a non-empty array of integers, nums, every element appears twice except for one. Find that single one. You must implement a solution with a linear runtime complexity and use only constant extra space. Okay, so
So I'll give you a few examples.
okay, so essentially we just search through integer array nums, looking for the only digit that isn't repeated.
Mm-hmm.
Okay. Keeping it on. So it's, I guess I was asked some questions before I just started to try and solve this. So there's no chance of us having a non-empty array, correct? Since it states that we'll be given a non-empty array, just to be sure.
Yep. Non-empty array of integers.
Okay, non-empty array of integers must be linear runtime complexity. Only use constant x of space. Okay. So the first, I guess, solution that came to my mind, which I guess would be the easiest, would be I guess it wouldn't work in this situation, but I would say sort the array and then you can iterate over it, checking if the number next to the one you're iterating over is equal to it. But that would not be a linear runtime complexity.
What would be the runtime complexity?
Um, since we're sorting, it'd be n log n.
Mm-hmm.
And we can't use an additional data structure to check frequency, such as like a hash map, because we can only use constant extra space. So I'm assuming this would probably have to be more of an in place solution.
Let's
Hmm.
we don't need to use extra space. We can use extra space. Just linear time complexity. All I care is about time complexity here.
Okay. Time complexity linear. So right now I'm trying to think what would be up. I'm thinking of maybe doing a approach where we can iterate over an array, storing the frequency of numbers in a different data structure, and then check in that data structure if there exists one that hasn't been repeated. I'm just trying to think of what would be the best approach for that. Since a set will only tell us if the number exists, but yeah, so a set would tell us if the number exists, but there's a case where we run to the end and this actually yeah, but then it would be have to figure out the one that doesn't repeat, which would be okay. So I guess one solution that does come to mind right now, I know probably I don't know if it's the most optimal, but it would be we can go through each one of these values. We can store the value and how many times it occurs in a hash map, and then we can iterate over the hash map's value entry list and find the one that isn't repeated. This should be linear since we're only iterating over the array once and we're only iterating over the hash map values once. Yeah, I'm kind of blanking on other solutions, but that's the only one that's really come to mind right now.
Okay.
Yeah.
Sure. Go ahead and implement that.
Okay, so I guess before I fully implement it, or actually, did you want me to go through some pseudocode first, or do you want me to just go straight into?
I think just go ahead and implement that.
Okay, and do you want function creation as well, or just the pseudocode for the?
We want working code.
Okay, working code. So let's say class. We'll call it solution, and in here we'll have our function
Are we
public, and
using
then
Java or Python?
oh sorry, yeah, this is Java. I should have mentioned
Okay, you
that.
want
Yeah,
to
my
switch to
fault.
Java?
Yes. Okay. Java.
Okay,
Okay.
switching to the Java.
Yeah. And then I'll just get rid of this for now. Okay, and then okay, so then we want to return the.
But do we want to get rid of that main function? You eventually have to
Oh, I
rewrite
mean,
it.
if you want to, yeah, if you want to
We
run
want to run it.
the,
We want running
yeah,
code,
okay,
working
okay,
code.
yeah, okay. So we're gonna want to create a public function. It's gonna return int, which is the digit that we find, and we'll call this function return non-duplicate, I guess. Let's call that for now. Okay. So the approach I was talking about is first iterating over the list numbers, adding the frequency into a hash map. So first I'll just go ahead and create a hash map. So integer will be the value that the actual numbers in the number array. And the second, the value would be the amount of frequency of that or that number. So we'll just call this, just keep it simple, nums map. This equals new hash map. And then we confirm that the integer num will be empty, so we don't need to check for that. Okay, so now I want to just iterate over this array. We'll just do for 0 as less than our nums less than our integer array nums dot length. So I'd say if or there should be a okay, yeah, so we can just keep it simple. We can use nums map dot put, and then we can get the whatever the number is, nums I, and then for the value we can use nums map dot get or default. So essentially this will, if nums I exists in the map, then this will get whatever the current value is, which is the frequency amount. And then we can add 1 to it. But if it doesn't exist, we can just default it to 0. Meaning it'll put it in the hash map and then initialize it to 0. So this would be nums I are 0 and then incremented by 1. So this populates our map with all the numbers, and then now we can go over this map. I'm not okay, so I think the call for this, I'm trying to remember what the actual call for this is, but it should be I can't remember if it's
What are you trying to do? Loop over through the values?
yeah, so I remember in Java there was a function, I think it was hash map, like entry set
All
or
right,
entry.
on the top right, there's an AI assist. AI chat. Oh, it's currently offline.
Yeah, I think it's called entry set, but I'm not sure. Look in,
Okay, try ask the AI assist.
look through
Right.
sheet by hash map. Before I ask AI, I just want to process something real quick. Okay, so I can go over entry set. That gives me entry values. I can see. You set in the hash map, I can see which value is equal to 1, but I'm just trying to determine how to return the actual key.
It's fine to ask the AI because you could
Yeah.
just ask the AI.
Yeah, so look through hash map at Java. Is easy actually set. Okay, so map that entry. Okay. So we'll just do the map dot entry. And it's maybe integer and integer. And we'll put our entry in our nums map entry set. Okay, yeah. So this is gonna help us iterate over each entry in our map. Now we can see if, well, assuming, okay, so only one appears once. Okay, so we can just say if our entry dot get value equal to 1, and we just return entry dot get key. So this should go over each entry, finding which value is equal to 1, which is our frequency, and then I'll return the entry dot get key, which is the actual number. The only thing that we would have that I'm not sure if they'll complain, but I think it wants us to add just to prevent the function from complaining. I'm just gonna add an integer result value here, and then instead of returning, I'm just gonna say result equals, and then just return result.
Well, we know all elements except for one appear
Yeah,
twice.
no, I'm just doing this because in Java it's gonna complain if I can return it here, but if I don't have a separate return on here,
I see.
it's gonna complain. And I couldn't say like return -1, but I don't.
Yep.
Just for like, I guess, code reasons, I just think it'll be safer just to do result and then return the result.
Makes sense. Cool. Run it and see if it works
Okay.
on the examples.
Or run it on these examples. Sorry. So you would like okay. Let's see. I'm just gonna delete this for now, or actually I'll just cross this out for now. Okay, so I'm gonna create a and then s dot and then we'll pass in and this is complaining because the method so this is complaining. Fix that, and then we can wrap this in here. And then for now, I'm just going to run the one case and let's see if that runs. Yeah, so we got result of 1.
Nice.
And then we'll go 4, 1, 2, 1, 2. And then that'll result a 4. Yep. Then yeah, just 1, which should just be 1. Okay. Yeah.
All right. Okay. I'm gonna move on to the second question. You can comment out this function. So yeah, this is the second question.
Okay. So
We're pretty much going to be given an array of integers representing the daily temperature. We need to
mhm.
return an array such that the answer of each element is the number of days you have to wait before you get a day that's warmer. So, for example,
Okay.
for 73, you only have to wait 1 day until it's warmer because the next day.
Okay.
74, you only have to wait 1 day because the next day is 75. How many
Yeah.
days you have to wait? One, two, three, 4 days
Okay.
to hit something. So yeah, just fill in the output array like that.
Okay. Um, we can array. Okay, so just before I get into this, is there a chance that the temperatures array could be empty?
Yeah.
Okay, so I'm just gonna take note of that. It could be empty. Hmm. Is there any time or space complexity constraints?
Let's just have the most optimal algorithm you can think of. I'll tell you if it's too slow.
Okay. Okay, and okay, so I think the brute force solution that comes to mind would be having a nested loop. So I could say for I and compare every number in the array after I to see which one is the first one that's greater. And then I can store in the result array the index, in this case, we'll call it J.
Mm.
Um, Actually, no, it wouldn't be the J. It would be how many days. So that would be J minus I.
Mm-hmm.
And then that'll be the distance, so days that we have until the temperature is warmer. Um, that would have a time complexity of n squared,
Mm-hmm.
since worst case scenario we iterate over the whole list for every single n. Um,
Exactly.
yeah, but and then the space complexity for that would be of n, since but I think space complexity isn't too much of an issue here since we're returning an array anyways. Um, yeah, so that would be my brute force solution. I'm gonna I'm trying to think of a solution that might be more optimal. Um, so moving forward, here. Okay, so I'm trying to think of if there's a way to do this backwards. That way we can keep track of days ahead and work our way backwards. Um, there's-
what are you thinking? So what's the so your initial solution is O of n squared.
Yeah.
So yeah, why are you thinking about looking at it backwards then?
The reason I'm thinking about looking at it backwards is so we know that 73 will have a day before. We would have to worry about 73 having a day ahead that's warmer. So we can use this as our base. And then we can work our way backward to see, oh, okay, so we're at 76. Is there a day that exists ahead that meets our requirement? If it doesn't, then we just, I guess, have an O of n solution working our way backwards, storing whether if there is a day, what is the distance and or zero otherwise. Um, yeah, so that's kind of the headspace I'm in right now.
Mm-hmm.
I'm just trying to process some issues that we might run into as yeah. I guess just for sake of time, I might just want to code out the brute force first just to have a solution down.
Let's try to get the optimal here.
Okay.
Quadratic will be too slow.
Okay.
I want something faster than n squared.
Okay. Um, okay, so I'm trying to think if this would work. So what I'm thinking is we can kind of have like a two-pointer approach where we can see if so we can have our left pointer here and then we can have a right pointer. Now increment, they'll keep moving forward as long as it's not big enough to fit this requirement. And so, for example, let's just say this was like 72. So the pointer would be, for example, the right pointer would move here.
Mm-hmm.
And then we would compare, okay, we finally have our match. 73 is bigger than 75. And then once we still have this big number, we can keep comparing every element up to it until we have to move it again. But
So you're gonna have one pointer, say left, and then a right. We're
yeah,
gonna move right until match, and then we're gonna say okay. The result of that is 2, and then we'll keep moving this up.
yeah, keep moving it up until right isn't sufficient anymore. But I feel like we would run into a couple issues with that because, for example, if we get to 76 and there was like four numbers here, for example, they're all 73, it will just eventually keep going. But actually, that might still work since it will just be zero
Well,
zero.
like if we have 71 here and we find
Yeah,
76,
yeah.
we say there's 4 days until 71, right? But then
Oh,
we go to
yeah.
69. We'll say there's 3 days until there's
All
something
right, 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 right. All
greater, but
right,
it's
right.
only
I
one
forget.
day.
I forgot the. It has to be the next day, right?
Yep.
Or first day.
Mm-hmm.
Okay. So I don't know. I feel like I'm overlooking something here. Like this would be a lot easier than I think. Or yeah,
What could you explain the solution working from the back? How that would work? That you were mentioning.
yeah. Some I was saying that starting from the end,
Okay,
we can
start from the end.
yeah. So we can work our way backwards. So like we would see. So this has no. Since this is the last variable, we know it's going to be zero because there's no days ahead. And then we would move over to 76, and we know that there's no number like this gets bigger, so we move backwards again. The only issue with that is I'm fine with just moving one increment, like just incrementing backwards like that, but I'm just contemplating how I would move the second pointer backwards and keep track of that.
So you're gonna have two, you're thinking
Mm,
of doing 2 pointers here.
or no, I'm just thinking about how I would keep track of which. Um, so, for example, like if I hit 70, or let me see, well, I'll use, for example, if this was 71, or yeah, if this was 71, so if this was, for example, 71, and I'm, okay, so this is 0, this would be 1, this would be 72, right? So this doesn't fit it, but I'm just determining how I would tell this number that this number exists. Uh,
Yeah. Is there any maybe data structure that we could use?
so I So I don't think set would work here because the set only stores the existence of numbers. Like I'm not sure if we could actually check if there's a number operator that exists in there. So I don't think that's a viable solution. Um, we could actually. So okay, so I think we actually might be able to use for the stack here. Um, by so I think we would. I'm just trying to process it. I think we would just push.
Yeah, sounds a bit promising. Maybe using a stack.
Yeah, I'm just trying to process how to keep track of things. So we could keep track. I would probably push in temperatures. And then okay, so I would start by just pushing in every valuable stack. But as we're iterating over the list, I can check if if the current I is greater than what's in our stack. I would say. Um,
So you can push every element into the stack. Like,
oh no, sorry, not every element into the stack, but I would push elements into the stack and check if whatever I is, for example, so if I have these pushed in and I is here, I would check if whatever's at the top of the stack is less than where I is. And then I would use that to determine. Uh, so, for example, we push 33 or 73 in, and then we push, and then we go over here. We're like, okay, is this value, temperatures I, is it greater than 73? So, no, it's not. So we would go here. Now this is where I is. We'll say, okay, is 75 greater than the first value in um, actually would yeah, if that value is greater than 73 and it is, so then we can use that. That's gonna take a while to get the index. The index would be um, yeah, I guess we could have a pointer for wherever we're currently at. And then, so for example, yes, we have stack here, and the I equals 0. So this is the one we're working with right now. So we add this. Since our stack's empty, we add the first element. Then we go here and we say, okay, is actually I'm wondering if, because that's last and first, if Q might be better in this situation if I'm doing
we're actually at
actually.
time now. About 20
Okay.
minutes. All right. How do you feel about it? Like how do you think you did on the interview?
I think I did better in the first question for sure. The second one, I kind of, I don't know, I started kind of blanking and I just forgot like resources I could have used, such as like a stack or a queue or whatever other data structure. I was kind of more like my mind was still on the hash map set space.
Yeah,
So I think being stuck in that headspace kind of drove me into like kind of like a hole, and I was kind of struggling to think of a more optimal solution.
I see. That's
Yeah.
okay. Yeah. So okay, let's talk about question one first. I think yeah, it did a good job with understanding the arrays, clarifying the question. You
Yeah,
mentioned the hash map solution, but I
yeah.
think what the main thing here would just be getting that algorithm done way faster than you did it, because
Mhm.
I counted it was we started at around, or it took almost 20 minutes to completely implement the code. So I think
Yeah.
just getting through it a lot faster will give you better chances at your interview, because
Mhm.
especially if they give you an easier question, they would want
Yeah.
you to solve it like pretty fast.
So
So
by
yeah,
solving fast, are you referring to the coding portion or the coming up with the algorithm or both?
I, for both, I
Okay.
think yeah, being able to code it fast. So I would say you should be able to solve that question between 5 and 15 minutes, and then you should be confident that that I think what happened is you weren't really confident with this hash map solution. You were thinking maybe there's something faster at
Yeah.
first. So I think yeah, it all just comes with a lot of practice, but you should be able to identify the solution faster.
Mhm.
And you identified it, but you were a little bit unsure about it. But being able to
Yeah.
cycle through different possible solutions and then understand for sure that the solution that you have is gonna work, and then
Yeah.
implement it really fast. So
Mhm.
that all comes with just practice.
Okay.
So I think even with the
Um,
second question, you're having trouble iterating through different possible solutions and then
uh-huh.
finding one that works. So I think it's all about just practice again for that. You had a question?
Yeah. Uh, no, I was gonna say because originally for the first question there was a space complexity constraint. So what would have been the optimal solution in that sense?
There's like it's a weird bitwise one. That's why I quickly removed it when I realized
Oh,
it.
okay.
So, but yeah,
Okay. Okay.
that's not. I wouldn't ask that question in an interview. So that's why I removed it as fast
Oh,
as
okay.
I could. But yeah, I think yeah, you solved it. The solution is clean. It would just be implementing it a lot faster. Because if you look
Okay.
at it, you should be able to implement that pretty fast. The
Hmm. Yeah.
that question. Um, yeah, second question is more just being able to iterate through all of the possible solutions faster. The way to
Yeah.
solve this question is actually using like a monotonic stack. Like, and the
Yeah.
way I like to do is go from the back.
Uh-huh.
So yeah, I would just take a look at that. So how would
Yeah.
you do that is pretty much you just look at 73, because essentially for each one you just kind of you just need to know what's the next largest number to my right.
Okay.
So if you move backwards, you should be able to figure that out. So 73,
Yeah.
you put that into stack, should be monotonically decreasing. Oh yeah, okay. And then you see 71.
Uh-huh.
71. 71. There's something larger than 71 to the right, which is 73. So you could pop 73 out. Or I think you could
Okay.
keep 71 on. Something like that. I need to work through the solution again, but the solution is would be like a monotonic stack, and I like to work from the back on
Yeah.
that
Because my
question.
only concern, because I was kind of thinking that direction, but my concern was I took 76 out here, right? So
Mm-hmm.
what if there's a case where we popped these numbers, for example, and we came to 75 and these no longer exist?
When you
But
pop 76,
76, or sorry, if 76 was in here and we got this out of our stack and then we hit 75.
yeah. So let's
Yeah.
explore. So how I would work through the solution, I'd be like, okay, um, how I solved this the first time when I saw was that what I just need to know was what is the element to my right? What is the first element to my right that's larger than me, which is 76. That's
Hmm.
why I came with the idea to work on it from the back.
Yeah.
So let's explore different ways we can generate the solution from working from the back. Let's remove 76. So we put 76 here. Maybe store its index or something. If we go to 72, 72, that's one day. Maybe we could store the index of here. So let's track the index here. 0, 1, 2, 3, 4, 5, 6, So we could maybe just store in a tuple the 76 in index 6.
Mm-hmm.
72. 72 is less than 76. So it would only take 1 day, right? So maybe we just put 72 here. And then let's just move over to something like, let's remove, okay, wait, let's go 69. So it's monotonically decreasing.
Yeah. Actually, just thought of a solution.
Okay, what's your solution you're thinking?
I'm thinking like, what if we work backwards and we stored this largest solution, so 76, and we kept checking these numbers, and we know that if these numbers are greater than 76, there doesn't exist a solution or a day. But if we come across a bigger number, so for example, if this was like 80, this would be 0, but now the new highest number will be 80, and we would work our way backwards using that, if that makes sense.
I'm not sure if I understand that solution.
So yeah, I'll try to. Okay, so let's start with 76, right? So 76, we can say, like, for example, we have it stored somewhere like this: highest equals 76. So we know, okay, we work, now we go to 72. Is 72 less than 76? Yeah. So we add like 1. Is this less? Yeah. 2. Is this less? 3. So if this is, for example, 80, we know that the largest number that we've come across so far is 76. So there doesn't exist a number that is big enough for 80. So we write 80 as 0 in our array, or yeah, in our array, result array. And now we update highest to 80. So now we know that this is the highest number we come across. So if there doesn't exist a number like at 72 or 73 that's not greater than 80, then it's probably going to be.
We have 76 here, right? So we're saying this has a 0, this has a 2, or this has 1 day, or this has 1 day to wait, and this has 2 days to wait. But that's not the case. It only has 1 day to wait because the next day is bigger. So you need to keep that. That's why you can't just track the highest value.
Okay.
So, yeah, you need the stack here because pretend we just put in 69. Now we go to 71, right? Now we go to 71. 71 is 69 higher than it? No. So we can pop that out the stack. Is 72 higher than it? Yes, it's higher than it. How far is it away? It's only 2 days away if my index is 3. So
yeah.
And then we could just add 71 here. So you kind of need a stack to capture all the intermediate values. Because just maintaining the one highest doesn't work. But yeah, that's kind of the solution. Go ahead and try that one. I'll send over the question because people in the chat are asking what that question is.
Okay.
I think
I have solved this before. I just can't remember what solution I used because I don't recall using a monotonic stack. Yeah, I'm not sure exactly how. Actually, I'm not really sure if I actually ended up solving it, but yeah.
Yeah. Well, there's like. Yeah. Cool. All right. Thanks for coming on.
Yeah. Thanks again for the interview.
No problem. All right. See ya.